All right, so lesson 7, we're going to continue looking at functions, graphs of functions, and we're going to use the graphs to find the average rate of change. So in this lesson, we're going to be talking about the average rate of change. So goal number 1, I understand the meaning of the term average rate of change. Highlight it, underline it if you have it. That's going to be what this focus of this lesson is about. All right, when given a graph of a function, I can estimate or calculate the average rate of change between 2 points. Okay, so that is what we will be doing in this lesson. This is a skill that you have learned before, and I know for a fact we have talked about. They're just using a new terminology for it. So we'll get into that. 7.1, we have a temperature drop. Here are the recorded temperatures at 3 different times on a winter evening. So right here we have our input, or our X values as the time. Okay, and then we have our outputs as the temperature. All right, so we have 2 different opinions here. Tyler says the temperature dropped faster between 4 p.m. and 6 p.m. Okay, Tyler said it dropped faster between 4 and 6 p.m. May says the temperature dropped faster between 6 p.m. and 10 p.m. Don't say it out loud. Who do you agree with? Explain your reasoning. Okay, I want to give you a couple minutes. I want you to look at that table. Which one of those temperatures dropped faster? Okay, that's the specific terminology they chose to use. What does it mean for a temperature to drop faster than the other one? Now, look at both opinions. Look at the difference in the temperatures and write down who you agree with, and give me just a short little bullet point of why you think that. Okay, don't say your answer. Don't tell it to anyone. When you have it written down, cover it up. I'm going to give y'all about a minute and a half to write me a little explanation, and then we'll talk about it together. What does it mean to drop faster? And whose did it? Ready, go. Don't show your answer. Just think about it yourself. You can be wrong. It's okay to be wrong. Because we're going to talk about what it means to be faster in this lesson. Minute and a half. Who's right? Tyler or May? About 30 seconds left. Give me a good explanation. Don't just write their names. Tell me why you chose them. Okay, so according to how the day works, your explanation is correct. But is that true for the actual temperatures and then times? So you said, I would say between 4 and 6 p.m. So it dropped from there to there. How much did it drop? Today and tomorrow. Okay. So it dropped 8 degrees. How did it? Which is 2 hours. So 8 degrees in 4 hours. So we're going to one of the days today, maybe 9 degrees. It should probably be so. It's up 8, it's up 9. It was a 2 hours, 4 hours. Which one was faster? We're going to talk about it. All right, let's look at it. So I want us to focus on the fact that they use this term, which one dropped faster, okay? So if you chose Tyler, give me your reasoning why you chose Tyler, Hayden. So Tyler's was between 4 and 6.
I said because you're dropping 4 degrees an hour versus 2.25.
Okay, so Tyler's dropped from 25 degrees to 17 degrees. So that's a total of 8 degrees. So Tyler's dropped 8 degrees over 2 hours. Okay, so Hayden said, okay, if it's dropping 8 degrees over 2 hours, how fast is that? So he did it and simplified it to see how fast that was over at each hour interval. So if it dropped 8 degrees over 2 hours, he said it dropped, which is 4 degrees per hour. Okay. We'll come back to that. All right, now if you chose May as your choice, someone explain to me why you chose May. Did anyone choose May? So y'all are familiar with that term faster. Now, let me choose a different color. So May chose between 6 and 10 p.m. Okay. And if you didn't understand what it meant by faster, you may have said, okay, well, it went from 17 degrees to 18 degrees, which is how much? It dropped 9 degrees over 4 hours. Okay, so you say, oh, Tyler's dropped 8 degrees, May's dropped 9 degrees. May's dropped more, hers is faster. Okay, why is that wrong?
Because, yeah, she had like, how many hours? She had 4 hours and.
Okay, so hers had a longer period of time. So it dropped 9 degrees. It was 1 degree higher, but it was 2 more hours than hers. So how much is that per hour? 2.25. Okay, so which is 2.25 degrees per hour. Okay, so when we're talking about that term faster, I want you to think of the term rate. Okay, when we're talking about rate, we're talking about how much something is changing over a period of time. Okay, so this is changing 4 degrees over a period of time. This is changing 2.25 degrees over a period of time. Which one is faster? Tyler's is faster because it is a higher rate. So write that down. Faster because his has a higher rate. Keyword there. Which y'all have done a great job into leaning into what this whole lesson is talking about. So, all right. So because Tyler's had a faster rate, his was the faster one. It dropped less degrees, but it was a shorter period of time. All right. Keeping that same idea, let's look at the next activity, 7.2. Actually, pause real quick. Okay, so here is a graph. It is displaying the temperatures at a specific time, specifically since noon. Okay, so this is the temperature at 4 p.m. and the temperature at 10 p.m. How did the temperature change between 4 p.m. and 10 p.m.? What did it, you don't have to tell me how much it changed, just how in general, what did it do? What did the temperature do?
Yeah.
It dropped, okay? How can we tell?
um,
How do you know?
One's higher than the other.
One's higher than the other, okay? So one was what? 25 degrees, and then one was 8, okay? So with what we know about temperature, what did it do? If it dropped, that means it got
Older.
colder. Awesome. Okay, now, how much did it drop? How can we figure that out? 25 minus 8? Okay, so 25 minus 8, 17?
Yeah, yeah.
Yeah, 25 minus 8 is 17. So how much did it drop? 17 degrees. Hold on one second. Does that have any question? Can you tell how fast or at what rate the temperature, so how fast or at what rate the temperature was falling? If so, how? Okay, so there it is. How fast was it dropping? Just like what we talked about in the last activity. How fast did it drop? Look at the time. How much time passed? It went from 4 to 8, or I'm sorry, 10. Yes, sorry. So 4 to 10, how much time is that? 6 hours. So it dropped 17 degrees over 6 hours. 17 degrees over 6 hours. Okay, so Haley and Hayden told me it was what? With a bunch of 3s, 2.83. So how did Haley and Hayden know that it changed 2.8 degrees per hour? What'd y'all do? 17 divided by 6. It changed 17 degrees over, literally over, 17 over 6 hours. So if we just divide those, because we know that this little line just represents a division sign, right? Fraction is just a division problem. 17 divided by 6, which is 2.83 repeating degrees. So this is hours. So it's degrees per hour. So were we able to find the rate with just those 2 points? Yes. Okay. Last question. It says, if not, why? Okay, where we were. So now looking here, same situation, temperature, hours since noon, but this time, what do you notice? There's a lot more points, okay? So we have a lot more information now. It says the table and graph show a more complete picture of the temperature changes on the same winter day. We have function T. What's the name of our function? T. Okay, that's all. Anytime you see a T throughout this whole problem, that's all it means. That's just the name. You don't do any math with the name. It gives the temperatures in degrees Fahrenheit, H hours since noon. Okay, so we have the temperature and we have hours. Which one is my input?
Temperature. Wait, no, hours.
Hours. That's time. So that makes temperature my what?
Output.
Output. All right, and you can see that in my table too, and my graph. Okay, in my table, this first column is always my X. It's my hours. And this second column is always my Y, or my output, in this case, temperature. And you can see that represented on my graph as well. All right. It says find the average rate of change for the following intervals. Explain or show your reasoning. Now, the rate of change is talking about how something, whatever you're talking about, is changing over a period of time. So whatever your Y value is, in this case is temperature, is changing over a period of time, your X value. So your Y value over your x value, your change of y over your change of x. What does that sound like? The change of y over the change of x?
Slope.
The slope. Sounds a lot like slope. So we're trying to find the average rate of change between the following intervals. So let's look at this first one. Between noon and 1 p.m. All right, so let's look at that information. So, yeah. So noon. This is the time since noon. So where am I going to find noon at? 0. Okay, so at 0, what was my temperature? 18. Okay. So I'm going to look there. Boom. 0, 18. All right, what is my temperature at 1 p.m.?
19.
19. All right. So we're talking about the change of our temperature over a period of time. So let's do temperature over time. Okay, how am I going to find the difference in my temperature between 1 p.m. and noon? We just subtract them, okay? So let's do 19 minus 18. You could have done 18 minus 19. You'll get the same answer. Okay, but whatever one you choose to use first, you have to use its correct x value with it, okay? So what was the time when the temperature was 19? 1. What was the time when the temperature was 18? 0. So we have to do the change of the temperature over the change in time. All right, so let's simplify that. What's 19 minus 18? What's 1 minus 0? 1. 1 divided by 1? So how much is it changing per hour? 1 degrees per hour. Write it like a rate, because that's what we're finding. The rate of change. You have to write it as a rate. All right. I'll give you 2.5 minutes. Do B and C. If you finish before time is up, try looking at number 2 and see if you can figure it out. 2.5 minutes. Actually, just do B and C, because that's all we're going to have time for. B and C, ready, go.
Can we talk far?
Yes, you can talk in groups. Yes, absolutely. About 1.5 minutes. Yes, sir.
I got a negative.
Yeah.
Between noon and midnight, got 18. Yep. And that would be 18. Minus 7, which is 0. What's 18 minus 7? What's 0 minus 12? Oh, 12.
About 20 seconds left, and then we're going to talk about it real quick.
Because then they got negative 12.
On number C,
Yeah.
we'll talk about it. I know it is a negative. I don't know if it's negative 12.
Yeah, it is.
Okay.
0 minus 12.
Okay. But did you do the difference in you have to do the temperature over the time. So take whatever that temperature is and divide it by whatever the time difference is. All right, so real quick, let's look back at A. We said the rate of change was 1 degree per hour. If we were to look back at that little interval of time between noon and 1 p.m., what is my little line doing right there? Is it increasing or decreasing? It's increasing. So we said average rate of change is very similar to what we know about slope. Okay, so the fact that this is a positive number makes sense that that little line is increasing, right? All right, so let's look at the next interval between noon and 4 p.m. So I'm going to use purple this time. So I have noon and I have 4 p.m. All right, so what is the change of, we know the rate is it's the change of whatever our variable is over time. Okay, so what is my temp talking about between noon and 4 p.m.? So we have 25 minus 18 over, what time was it at 25? 4. What time was it at 18?
0.
All right, what's 25 minus 18?
7.
What's 4 minus 0?
4.
Okay, so let's simplify that one more time. What's 7 divided by 4?
1.7 per hour.
What?
1.7 per hour.
1.7 degrees per hour. So if I were to connect my points at 0:18, which is right here, and 4:25, boom. Does it make sense that the average rate of change is a positive number?
Yes.
Yes, because what's my line doing? It's increasing. Last one, and then we're done. Okay, it's between noon and midnight. Okay, so once again, all the way up here and midnight all the way down here. So it's the change of temp over a period of time. I don't want to run out of time. Okay, what are my two temperatures?
18 minus 7.
Okay, so we have 18 minus 7. What's the time at 18?
0.
What's the time at 7?
12.
All right, what's 18 minus 7?
9.
11.
Haley told me wrong. I'm sorry, Liz.
What is 0 minus 12?
Negative 12.
Negative 12. Okay, now what is negative 11 minus 12?
Negative 11.
Positive 11 divided by, I'm sorry, let me rephrase. What is 11 divided by negative 12?
Negative 0.91.
Negative 0.91 degrees per hour. Or you could have left it as a fraction, but this time my average rate of change is negative. Well, let's look at those 2 points between noon and 12. What is my line doing? It's decreasing by negative 0.91 per hour.